Hello, everyone. Welcome to today's CNCF TAG Environmental Sustainability meeting. Today is Wednesday, the 31st of January. We have today a presentation, but before we get started, I would like to point out the CNCF Code of Conduct. So this is a community meeting, so it falls under the Code of Conduct, which can be summarized to be just excellent to each other. Thank you, everybody, for attending this meeting. Is there anybody in this meeting who would like to introduce yourself? I don't think so, because I see a lot of familiar faces. If you want to say hi nonetheless, feel free. But I think we can go to the next topic, which is working group updates, and then we can go to Arne's presentation. So starting with working group comms, Kara, would you like to give an update?
Sure. And actually, before that, though, do we have a note taker or do I need to be a note or I can volunteer myself as a note taker, but I'll have
That's
to.
great. Awesome. Yeah.
Okay. Um, so for working group comms, we have our meetings on Thursdays, and they are in the CNCF calendar. Myself and Trisha Cahill are co-chairs. We are focused on KubeCon EU. There are a plethora of blogs and content out there right now. I was out of pocket the last bit or the first bit of January, so working on a Kanban board to get everything organized, also working on updating our website. And we have a couple, I think a couple blogs I was mentioning that are needing to be written. And so if you aren't able to make a meeting, that's fine. You can still contribute. If you want to write, if you have a hankering for website design, if anything that you would maybe want to contribute from a comm standpoint, and also if there's something in region that you have that you want us to promote, we do have a working group comms channel. There's a lot of content within the main sustainability channel. So if it is something that you want the working group comms to promote, if you could just ping me or Trisha Cahill, or really or Christina, and happy to get it on our social, get it on our website. Any questions?
Do we have like an overview of all the tasks that we want to complete? So the blog posts and updating the website and so on.
There are a lot. So I am I'll be tomorrow sharing out the board just so you can kind of see what the roadmap is looking like for the remainder of the year. I know more will be added to it, but at least what we have as today. Right now it's just I know there was also an interest in a newsletter, so we're also needing to prioritize because there aren't a lot of us being able to do all this work.
All right, sounds good. Awesome. But all of the tasks are like in issues already, so
Yes.
we can track them. That's awesome. Any other questions for working group comms? If not, we can go to the next one. Working group green reviews. Nikki, you are here. Ross as well. Would you like to give an update?
Um, yes, so in the Green Reviews working group, now that we have all of the components in a cluster, we're focusing on metrics gathering. We have to, well, the first goal is to gather metrics for Falco when it's idle. So we're using that as a way to surface metrics from the environment, like energy metrics is one of the more important ones, but we also want to get metrics specific for the benchmark test for Falco, like kernel event rates. So we're doing a lot of work around, for example, the kubeconfig to have kubeconfig that has the appropriate roles that Ross can expand on. And yeah, we have various smaller issues, and you can find them in our project board as well. Ross, would you like to add anything?
Don't really have much to add. Yes, we're making we make good progress in the automation, and it's exciting now. We're working capturing the metrics, and we're looking forward to your presentation. I think that's really relevant to what we're working on, and looking forward to learning from that.
All right, sounds good. Are there any questions for working group green reviews? All right. Thank you so much for the updates, both working groups. So now we can go to Arne's presentation about his work, green metrics tool, all those interesting things we saw on the website already. I believe, Arne, you can also share your screen. There should not be like any restrictions, so I will just stop sharing my screen.
We'll give it a try. Cool. You should see the Zoom meeting at the moment. So Christina is seeing herself very prominently because this is what I have here on my screen at the moment. It's visible for everybody, so everybody can see my Firefox browser.
It's a black screen for me, at least.
Oh,
For me, it's starting up something. Yeah, I don't know.
Interesting. It's not supposed to be like this. Let me try again. Okay. Well, for me it says. Well, let me try switching the window. What do you see now?
It says you've started screen sharing, but it's still black.
Same here, yeah.
Sure. This seems like a Firefox issue.
Yeah,
Maybe.
sometimes it
It
sounds like Firefox.
We'll just log in when I need to. Okay, give it a try. Okay. Okay, let me try to switch over because I think I can only be in one browser doing video and microphone sharing. And I will see you in a second. Okay, should be audible now and visible, I hope.
Yes, can you hear you? Arne too joined the meeting.
So, but here I cannot share. It's not possible. Do you maybe have to give me the right in Safari?
So in this meeting, we don't have really like co-host, just the host to start and stop the recording. So there should not be like a restriction from Zoom. Do you have a presentation or?
We'll figure it out. I have a browser installed, just a heap, so
Okay.
a bit of using the browser, so cannot hand anything over, but I will just give permission to my third browser in a second because this one's usually locked down.
Yeah, usually the backup of the backup works.
30 seconds.
Yeah.
third browser. Okay, third browser. Share screen is available. I will click it. What do you see now?
Yay, I see Jacob and myself. I see.
Works.
There is progress.
We made it. Okay, cool. Yeah, so thanks for inviting me and having the opportunity to show you the Green Metrics tool, our open source tool. I refrained from chipping in earlier when you, Leo, asked if somebody wants to introduce himself, because I thought I anyway have a talking slot later, so I will do that now. So my name is Arne. I work at Green Coding Berlin. Green Coding Solutions. We are in Berlin, and we're a small team. 3 engineers and 1 person that helps us with marketing. And we do mostly consulting with companies when it comes to sustainable software and in general, green IT, green sustainable transformations. And we do all of our tooling that we use as open source tools. So I think this is also how you get hold of us, through the Green Metrics tool, which is the tool that we use most extensively, so to say. And I think the intro to CNCF for us, and I think to you, Leo, in particular, was that I pinged you on GitHub after having a talk with Max, where I said, hey, wouldn't it be super interesting if you have something like an SCER value for all your cloud products, or is this something that you're generally interested in? So let me bring over here the links that I had open, that I can just quickly jump over to them, and our website. So this was the initial discussion to just keep everybody in the loop. I said, hey, the SCI, I think everybody knows it in here, and the SCER is something that the SCI is something that our tool can do in an automatic fashion, and showed you a screenshot of how we did this, for instance, for Wagtail, which is this open source project that sits on top of Django, and a bit of how the tool spits out some metrics. And I will go in my presentation a bit in detail how that exactly works. And then my question was, hey, is this interesting for you? And can we think of doing a demo project or so? And then during the discussion, I already came to the work that you're already doing. I think, Nikki, this is your domain at the moment, where you are at the moment, as I heard, looking at Falco and trying to do this with this infrastructure that you have provided as the CNCF. So yeah, and quick overview of what tools we have. Maybe if something else comes up at a later point, it's interesting for you. So the Green Metrics tools, what I will be demoing today, which is this automated system that brings you in the end an SCI value. It can be also integrated into something like build pipelines, etc. But we also have tools like the PowerHawk. So we use it very often if any of you is on Mac and wants to try out a nice fancy tool that can sit up in the toolbar on top of here. Tells you which process at the moment is using how much energy. And as you can see at the moment, it's the Brave browser, because I'm doing this the screen share here at the moment, but I can see it also over time, last 24 hours, all time, etc. And we also, if you click on view detailed analytics, you also come to a web front end. So you don't have to share the data. It will be local in your machine, but you can, and then it will be uploaded to the Green Metrics tool. And there you can see your compute history, your energy apps over a prolonged period of time. 30 days is our current free retention. We also have something for pipelines. This is EcoCI, which you can hook into GitLab and GitHub and GitLab. And this is based on our machine learning estimation models, which is also open source. It's Cloud Energy, how we call it. It's basically a Python script where you can give it some information, and then it will spit you out a value that's based on a machine learning model on the spec power data set, which I think some of you have already come into contact with. So my demo will be about the Green Metrics tool. So if you come to the webpage and click here on the Green Metrics tool. Also, one thing that I didn't mention, if you have any questions, I can not see you, so I don't see raised hands or something, so just chip in. I'm happy to make a break anytime and answer questions, because I think this is what the meeting is for. So just, yeah, voice your questions. This is for me the easiest. So if you are on the webpage, you click on the Green Metrics tool button, you come here to a bit of a very meager product page at the moment, but we provide basically everything here on this demo dashboard, as we call it. So it's fully functional. It's the open source and free version that we host. It's a bit of data retention, and you cannot hand in enormous amount of metrics, but generally it contains most of the functionality. So if you click on that, you will be greeted with something like this here. So it shows all the latest runs we have, and the tool works in the following way. So you can hand in a software, and the software has to be described in an infrastructure file. So this is for most of the clients that we use, this is a Docker Compose file. To show you how this, for instance, would look, let's pick out an easy example. I will pick out WordPress here for the moment, because I think that everybody does understand what the basic components are and how this works. So this lives in a GitHub repository, and contains here a under energy tests, contains here a MariaDB and a WordPress file, so 2 Docker files, and they are both aggregated in a Compose file. So just to keep everybody in the loop, it's a MariaDB like this, basically configured, WordPress configured. And then on top of that, we layer something that we call the usage scenario. So this is always the entry point for our tool. This can import a Compose file. It can also import other files, but here in this example, it's a Compose. You define what you want to do with it. So in this case, I want to make an SCI for a per page request. So SCI always has this unit of work. And then I say, hey, on top of that, I also want to have a browser that accesses this application in the end. So here we provide a Puppeteer container. You can also use something else. You can also make wget or curl or whatever you think is apt. And then you have something like a sequential flow, right? So you basically do commands from top to bottom. Here you can see we trigger a node script, and I will not show you, but I think you can guess what happens in the node script. The browser goes through different pages, and we'll go through this website as the Compose file has set the infrastructure up. The output is then something like this. So the tool goes through many phases. These phases originate from what we have here in Germany, from the Blue Angel for software, which is this software certification. So maybe also something that might be interesting to you. So the data that comes out of the tool can later also be used to get this software, this Blue Angel for software, which, to be fair, is a German label only, but it's one for software, so it's very rare. And it goes through these phases. So Nikki, as you mentioned before, you are currently doing baseline or idle measurements. So this is also what our tool does. So first it will check how the machine is when nothing is installed. So when no Docker container is running, you get the typical values. So like a power reading, like an energy reading. And if there's network, you also get network. And then the CO2 values connected with that. Then the Docker containers are pulled or built. Docker containers are started. And then the system is idled again. So if you have daemon processes, typically some load occurs already here. And then you have the runtime of the tool, so the actual flow that we execute. So something like the usage scenario or the customer journey or whatever it is you think that your tool should do, right? There's something, a functionality that you always have in mind when you come to a software. And then there's a removal phase, which at the moment is just removing the Docker containers. But if you have something more integrated, could also be purging caches. Tool shows you which of these phases has the most CO2 consumption. Obviously, this phase has to be multiplied, right? So your code is typically built one time and then reused very often. But if you have a function as a service, then this is a one-to-one relation, right? So the build is very often is this phase one time, and then every time the function is invoked, sometimes it can be recycled if it's still hot, but sometimes it can also be reconstructed. And then it becomes more relevant. So this is something that we provide here already as an overview. And the tool has very many statistics. So you can get all the timeline charts, drill down per container that is running on the system. You can also have here 1 million of metrics. I will keep this short for now and ask later if you want to have more questions. But basically, all of these are plugins. So you see here at the bottom what is at the moment set up. So I have here power for the whole machine. I have here a network capturing. So it basically captures the network packages, and through a heuristic or through a formula, it will get to a CO2 value. But I'm also getting the REPL values at the moment and the classics like utilization, memory profiles, etc., etc. but you can connect very many, and they are POSIX compliant, so they're very easy tools. But here for the moment, I think it shows what's happening. And yeah, and then you basically get the information about your code, how much machine power and how much energy it has been using running through that whole scenario. As you can see here, at the moment, the SCI value for this particular example is not shown. But if you go, for instance, here to the energy timeline project, this is something where we monitor software over time, so over the change of the software. And let's maybe hop into Nextcloud. I think this is a nice one. I will take the talk example. So here you can see that we monitor Nextcloud with this tool over time. So basically, we do it once a day, but you can also configure it to do it on every commit. I will show you in a minute how that works. And every color is a different commit. This red and this red have nothing to do with each other. So the colors repeat after some time, right? So every time there is a color change, it's a new commit. So this commit, and here three measurements on one commit, and here a couple of more measurements on one commit, and here the commit changes. And you see there is a bit of jitter generally on this energy signal also. But also if you give it a bigger time frame, you can see also trends in the software when actually some bigger changes have happened. So for instance, here you can see the software really has here decreased in its energy consumption, at least for the CPU energy that has been happening here. And then you can drill down from here. So if you click on a bar, you see what actually was going on here. So there was a run ID tailed with it, the energy value, and also what was the commit hash at the point in time. And you can diff these runs, for instance, right? So I'm currently have clicked on this. So I would diff it now with the previous run, and it would tell you, hey, it takes a bit to load. And it will take you, hey, okay, this is changed. So the machine energy has dropped 5%. Machine power has dropped by this amount, etc., etc. It will show you comparison charts, overlay charts. So here you can see every metric in this polar chart or radar chart. I don't know under which name you know it. And also how the phases compare each other. So you can make a drill down which phase is actually relevant to go into. And if you, that is currently something that we don't have public in the community edition, but you can also drill down what actually has changed, right? So there will be a git commit, git diff between these two, but also a diff between the machines. So what has actually changed in the infrastructure that you have been running, right? Because if you go here into the code, you can see that we capture very many machine data. So what processes have been running, what is the version of the current installed Ubuntu packages, what Docker client are you using, et cetera, right? And this can then also be diff because sometimes the change is not from the code that you have done, but you have maybe just updated your Ubuntu system or so. And this is what the tool can do in an automated way. Yeah, and I think given the nature of the title of the talk that you have here filled in, this automated SCI measurements, the power of the tool comes from these statistical comparisons. So as you've seen before, in this timeline, you can compare the software over a longer period of time, can diff specific measurements, but you can also apply this diffing every time here. So if you could for instance say, okay, although this would be a very comparing apples to oranges, but just now to show you the functionality of the tool, you can also say, hey, please compare these two software products to another, right? And you can click compare these two runs, and the tool would give you a value that comes out of it. Obviously, this is a bit tricky because I'm comparing here to an idle scenario to a unit test from Django, but you can also compare two iterations of a software against each other. So to show you an example, maybe here Nextcloud. And then here you would see it's currently here on this commit hash, right? And here is on this commit hash. And then you could compare these two versions against each other, click on compare, and it will show you, okay, how has this version changed to another? But you can also say, okay, let's take the last 3 runs of something particular, or here the last 2 runs, because I just have it here in my view. So I just take these 2 and they are, they're not the same commit. I want to have them on the same commit to make my case here a bit better. Let's see where we find that. So here is both time the same. It's again Nextcloud base. Here we have it. So Nextcloud talk, MariaDB Chromium. So we'll compare these two, right? So here we have measured the exact same software 2 times. And here the question for me is not how does it compare, but more like what is the standard deviance of these 2 runs? Like how much of a variation do I have when I do repeated runs? And you can see here you get not this plus 10%, but you get the average value plus the difference of these two comparisons. So it gives you a different style of comparison depending on what you want to compare, right? Let's say same software on different architectures would give you a different comparison, but also same software, same architecture, just repeated runs would give you a different comparison. And the tool always tells you in which mode it is currently executing this comparison type. Just to reflect that better, if I would make a diff here, it would tell me that it's now comparing commits, right? Here it's comparing this commit versus this commit, and this gives you then a different style of display here. And to conclude my whirlwind tour of the tool, so this also has an API, so you can query the data if you want of it. We also supply here Python notebooks, how to get the data out, but just to show where this API lives, it's just under api.greencoding.io. It's a self-documenting API, so it's just REST, you can get the data out of there. And if you want to hand in a run, you can just click on measure software, and then here you have to just fill in the software that you want. And as I said before, the consume point is this GitHub repository, right? So you have to hand in some GitHub repository here, like this Nextcloud one, and then just select the hardware that you want to use. As you at the moment you see, we have here 3 hardwares which are in this free community tier, active, and one that is premium. You select your measurement interval 1 time or multiple times or whatever, variance testing, and then you click submit, and it will pick up by the cluster. You can also always see here under status how many machines we currently have online. So at the moment there are 4 machines ready to take a job. These machines are currently under maintenance, or this one's not active at all. It's just a development machine. And you can see what they have configured, what version the tool is running on, because also we do constant updates, and you want to see what kind of version of the Green Metrics tool itself it's running. And a lot of more information. I think the most interesting information is how long you have to wait. So at the moment here, you have to wait 0 minutes if you hand in a job. This one has currently 2 jobs in the queue. And actually this one, yeah, there's a different reason why this shows 5 minutes. I could tell you, but I think it's not too relevant for the moment. And also the job queue, what is coming up next. And this is the Green Metrics tool as we have it at the moment. As a product, we also have an open source tier where you can hand in software and get these SCI metrics out of it. Just coming back to this one more time, so you have a bit of an overview of what we have looked at already. So we try to aggregate it for the softwares in these scorecards, as we call them, right? So we have looked at Nextcloud before, Wagtail, WordPress, but also databases where we compared with standardized benchmarks like these TPCC ones. And then you can, for instance, say, how does PostgreSQL relate to MariaDB when we do a TPCC benchmark? Maybe for you in the cloud, TPCH is more typical, but we've chosen this, and you can see that Postgres actually has a very reduced value of carbon when it comes to the standard TPCC warehouse scenario, which covers create, select, update, and inserts. And this is how we look at software when we say, okay, I want to get a first glimpse as a developer. I want to get what for a typical use case for a database, in this case, select, update, and insert, what the database generally uses, so I can factor in carbon as one of my decision factors for the software. Yeah, and now coming back to the initial thing, we suggested this to you if this is interesting for you, and if you have any project that you might be interested in, do something like a joint project and measuring for a CNCF project, a carbon value or an SCI value with our tooling, where we provide also this free open source tiers. That was my whirlwind tour, and I hope I could keep everybody on board. And yeah, happy to talk.
Thank you. Yeah, that was great. I have quite a few questions. I think I have 7 questions, but I might. Well, so I think you're using bare metal machines. That's how you are able to get the energy from RAPL directly, right?
Yeah, we have bare metal machines, and yeah, sorry, I just had a different idea about it, but just tell what I wanted to say. So we have bare metal machines that have a RAPL signal, but they also have all an attached power meters. So we have we use development boards that have very accurate power measurements, which is like in the microsecond range, and they are attached from the outside. So you can think of it as something like an elaborate IPMI.
Right, because in the Green Reviews working group, since our goal is to do it in a cloud native environment using cloud native tools, we are, well, actually we're using Equinix, so we are using bare metal machines. So we do also have access to RAPL, but we are using Kepler. The other question I have, because I do want to leave room for other people to ask questions too, how are you generating the load for the tests? Do you have that scripted? You have like, you mentioned that the functional unit is often a request for a web page. So how do you generate the load? And do you have like a duration of time for how long you're generating the traffic for? Or do you, because we're looking into how to do that and in a standardized way, in a replicable way, and we're looking at time durations, repetitions, and that's my question.
So the way that you do it is you're free to do it whatever you have. So when we work with clients, they typically have something like regression tests already, right? And then we use that because this is the most accurate representation of how the software will be in the actual use case. If you have something like a web page and you have a customer product that is web-based, then you have often like a user journey that is an end-to-end test already. So it's like a Selenium file or so, right? If I will dive a bit with you into the example applications. So if you go to our repository, there is something that we call example applications. And in here are very many cases where we have outlined this, how the tool operates given certain stressors. Yeah, so the easiest stressor is if you just use the stress command line tool. So here we have a simple test where we just stress the CPU for a couple of seconds. And this actually really is a CLI call, right? So you just say stress or stress ng, 10 cores, 5 seconds, and Q is just for quiet. Yeah, right? Then the resulting scenario will be 5 seconds long. If you have something like a machine learning model that you want to train, so here's a very easy example. There in the usage scenario, I'm just calling a Python script, and in this case, I'm actually doing a hyperparameter tuning. It's not a training directly, if you want to put it like this. This just takes how long the machine takes, right? So here you don't have a time capped operation. You have more like an event capped operation, right? At some point, the metrics calculation has finished. And for something like, I don't know what Falco, for instance, does in particular, but if you have any product, it will be something like a use case for this particular product, right? Either you have something like a regression test. Here we have, for instance, also a JMeter example, where we have here the testing plan set up, and then the trigger in the green metrics tool, where JMeter triggers a certain regression test. And here this is for a shop where the unit of work is an order. So here are a certain amount of orders and product addings to the cart triggered through JMeter. And this would be then your unit of work that you define. But the tool can trigger anything. It can trigger a headless browser for a web application, can trigger a command line call. It can also start a container if you have something packed in a container that needs to trigger something. This is how the tool does its usage scenarios.
How are you converting from energy to carbon? What is, where is that conversion happening?
So
the rapid fire questions.
Yeah, sure. I mean, that's what I'm here for. Getting back to an example again, to the machine idle, it doesn't really matter which. So this is a reading that we get, right? This comes directly from the reporter. The energy is obviously just the power over time, so we just multiply it with the time, and then we come to that point. We do it step by step. So every, I think the reporter here is configured on 99 millisecond resolution. So every one of these small time and energy blocks is multiplicated, and then you need to multiply it with the current carbon value of the grid, right? In this case, we are using a static reporter because this has run on our cluster, and we use just the standard value of the German grid, the average value of the last year. But we also do have a carbon reporter that ties into Electricity Map's CO2 signal API, which I think at the moment has a 1 hour, best case 15-minute resolution. So these are the two ways that you have, or you can also use a different constant factor. So this is also something that the tool allows. And this is something that has to be configured in the usage scenario, which, sorry, not in the usage scenario, I'm giving you a false info. Let me quickly jump to GitHub. This is something that has to be configured in the tool already if you set up the cluster. So if you use our cluster, you're bound to the configuration we do. This is all here in a config file. Here you can define, this is just for the cluster so that it always stays stable and there is an accuracy and measurement control profile running. And it is also temperature controlled. But here you can then select which reporters you want to activate. Like for instance, here you would uncomment the REPL ones, or if you're in a very restrictive cloud environment, you could also uncomment all machine learning models, and it will give you an estimation of the whole machine power, even if you don't have IPMI. And then you have to fill in the SCI values of the hardware that you're using, right? You probably know these values, like how long do you plan to use the machine? What is your share or splitting factor? What is the total embodied carbon? And what is your current grid intensity? So 475, as it is also given here in the documentation, is the value that you come to. And I think you know the formula. Once you have the power of the machine or you have the energy, you just multiply it with this grid intensity factor. And the same thing is true in the SCI for, getting back to here, the same thing is true in the SCI if you want to get to something like the machine, like the manufacturing time, right? So here you have to multiply time with the embodied carbon, and this is something that the tool does for you automatically if you give it the correct configuration values.
That config file that you shared before is really interesting. Could you share it in the chat, please?
Yeah, so here's this is just the example though, right? So you can see here
Right.
there's a lot of stuff not filled out, but you get an idea how this works. Maybe better is the docs on this one, I think.
For our the way we were planning, what we're planning on doing is, so Kepler has a Prometheus query that takes the energy metrics in millijoules and uses a carbon coefficient, just any value. It can be hard coded, or it can be, in theory, you could make it be a request to electricity maps, and then it converts it. So it's a Prometheus query that achieves that. But yeah, it's interesting to see two slightly different reference architectures, and it would be interesting if you were to do the SCI for Falco to see, for example, how you would achieve that, and maybe we can learn from, you know, how you approach it and kind of sanity check our own assumptions and if we're on the right path.
Yeah, would be interesting which scenarios you run, right? Because this is, I think, the most important point. If you just have it in an idle mode, you can just send me the infrastructure files that will set it up for me, which will probably something like Docker containers or a Helm chart. I don't know what you have, and then I can bring this into our tool. Yeah.
Okay, we'll follow up after this
Cool.
call for that. Does anyone else have any questions? 'Cause I could keep asking questions, but please, if you have questions, go ahead.
I just had a question back on test timing. You were saying that the duration depends on whichever test has been run, the regression test. But for
Yeah.
example, like the idle test, you run that for kind of 5 minutes. I was wondering, because is the idle test the same for all tests?
Yeah. So there's the idle test that I just showed you, right? So where is it? I hope this one is agreeing. This is a specific usage scenario where we do an idle test. The reason for us is to baseline the cluster, right? So this is a test that always, you can see here, it always sleeps for 300 seconds. And the idea that we have with this test in particular is to just see how the machine behaves over time. So if this profile, so we're typically looking at this value here because REPL values tend to fluctuate a lot still. So the machine power is usually the one that we use at least for baselining the system, and we want to keep a standard deviation typically between 1 or 2% max. And this is where we use this test here. However, what the tool always does, in every measurement, it goes through these phases, right, that I've already explained before. So the duration of that phase, for instance, this is always the same. So this is comparable between runs and also comparable between software. To be fair, 5 seconds is a value that I would not necessarily recommend. If this is something that you want to look at, you should do it for at least a couple of minutes, right? So something like this or recommendations like this, we also try to aggregate here in our best practices. So we have some best measurement practices also on the docs. I can also put this here in the chat. You might have more. I mean, there are a lot of best practices out there, but these are some. And for instance, running an idle test for a prolonged amount of time, like 5 minutes, is something that we have seen comfortable. But for the free product that we have, it's just, it will consume up too much stuff because people are mostly interested in getting a first glimpse, trying out our product using the open source version. So we have trimmed it down there to 5 seconds. And if you want to configure that, this is something that lives in this config file. You can just set it to an arbitrary value.
Yes, because that's also because I think that's really useful to know about having an idle measurement for the node. I think we probably want to do that for the machines, but also we want to have kind of an idle measurement of Falco itself, the tool we're measuring, and then run like a regression test or run a test that captures the dynamic values for that. But yeah, that's really useful to know on that, measuring the node itself as well. I was also wondering about the extra metrics that you capture. Obviously, we want to capture energy, but we're also looking to capture like CPU and memory to have a kind of comparison. Are there kind of standard metrics that you always capture, and like which ones do you find most useful as well as energy?
Yeah. So if you go to the docs and you go to the metric providers, you can see what kind of metrics you can currently connect through our plugin infrastructure. So just like GPU energy, we have different providers for whole machine power. This MCP is the system that we're currently using. So just to show you what this is, it's kind of like a box like this that is on the outside. I'm trapped here, let me go back. But you also have these classic metrics like what is the current total memory use, what is also the REPL memory energy, what is the CPU frequency, what is the fan speed, what is the temperature, what is the CPU time, what is the CPU percentage. So you can connect all of these metrics. And if you are looking to hand in a run on the cluster, you can also see here under details which providers are currently connected on the machine if you hand it in, right? So if you plan to hand in on the Fujitsu Esprimo P956, you can see here if it has the metric providers that you want. And these metrics will then come out in a measurement with this particular machine in the Green Metrics tool. And to also follow up which net metrics do we typically find most useful, it's this configuration. So this is what we use the most. If we debug measurements, we use other ones. You want to have also something like frequency often integrated, but very often CPU frequency is something that is more noise than helpful. So this is why we have typically turned that off, at least here on this particular setup.
Thanks. I don't have any more questions right now. If anyone else has got questions.
Okay.
Thank you so much for the presentation. I think it looks very comprehensive in a way that there's like a lot of pages, a lot of data. Reminds me a little bit of TestGrid. I don't know if you know about that, but we use it in Kubernetes to monitor all the tests, detect flaky tests and so on. And it has like a similar vibe to it that you can dig through it and dig more and so on. I think that's very, very useful. So congrats already on this open source project. And I think it's also great that it is an open source project, so we can actually learn from it and see it. One page which I find also quite interesting was there was like a page which was like it showed like the energy usage during the boot up time, idle state. So basically just like I think it was like a very natural way to look at the data. We have like different usage scenarios, but you also have like different times when the software runs. Exactly that, yes.
Mm-hmm.
For example, this information is like very, you can quickly digest the data and see how it performs. And all the other tools are very like, if you dig deeper into it, need to understand, okay, I made these changes to the software. How does it actually compare? I think that's very powerful. I think in the Green Software Working Group, we have like a similar idea that we want to gather as many information as possible and then maybe at some point also slim it down a little bit. So I think this has, yeah, a similar vibe. Looks very comprehensive already. Great. One thing which I was curious about, how does actually the architecture of the tool look like? So there's like the databases, there's the website. How many components are there actually to host all of this? And is it constructed in the way that you can kind of don't have, probably without the website, it's a little bit, it's intended to have the website, right? But maybe it's not too important, but it would be interesting to, if there's like documentation about this to learn.
Yeah. So the documentation is very, very extensive, as I already said. You can just go here and look at the installation and how it works. Install on Linux. We have an install script that will set up all the containers for you. You can also run it on macOS and Windows. I didn't mention that, but generally works. On Windows, as usual, some restrictions. And there is the installation of a cluster, right? So this is the setup that we have. So if you try this out as a developer, you basically get a one install solution. It will create three Docker containers. So you basically have a web server that will deliver this view where you can look at the data that you have. You need a Postgres database that will store all the data, and you will have a Python API that is tied with the Nginx container that will give you the API functionality. But when we set up a cluster, we typically have this, what you see here. On this machine, only these 3 Docker container runs, and then this runner, which actually does the run, which is basically a Python script, that can run standalone on these nodes. So on a node that does a measurement, we have made the runner that way that it's extremely low profile. So it's just a Python script that's just glue code and executes a lot of POSIX calls. And also under measuring here, you find also metric providers, also an overhead look. So we will revamp that, but you already get an idea of how much overhead the tool is at the moment using for different setups, for different configurations. Obviously, as you know, if you create higher resolutions, you will use more energy because the reporters just use more. But you can also use less reporters. There's different configurations here. And you can also run these reporters standalone. So if you feel that the tool is too much for you to install in the cloud infrastructures you have, every one of these mini reporters here, so maybe we can hop into one specifically. So maybe we take the MCP reporter. It comes with metric reporter binary that you can just execute, and it will just output to the standard out the timestamp plus the energy reading, right? And let's maybe hop in the GitHub repository because I think this is most digestible for you. So they all live under metric providers. I'm picking out again an energy one, as I said before, the MCP one. And here you have a README. This one here is apparently to do, but under provider, you find the C source code that runs, you have a make file, and the output will then be this metric provider binary that you can just use. Yeah, so it's something that can be fully decoupled from the tool if you just need one particular component. Also, our REPL component is also decoupled. So it lives here under metrics, CPU, energy. And here, this one has a bit of more documentation where you just say, hey, just make sudo, etc. Source code is also pretty tight. So you can see here the reporters are pretty small in general. So we're just looking at a 500-line code of C, which is mostly boilerplate. So this is the minimum profile. If you want to create like a minimum profile, this would also be possible. But yeah.
Great, awesome. Yeah, very interesting. All right. So about the open discussion, we will also look at this a little bit further. I think it's like the collaboration. I think this would be very helpful. Great. Are there any more questions? Yes.
We do have our next meeting at the same time as this one next Wednesday for the Green Reviews Working Group. If you'd like to join, and because maybe there are components that we could reuse. I know for sure that we don't have the embedded metrics, so the unit for the embedded carbon, which is part of the SCI. That's something we're missing, and we really have no. We haven't even started, into how we would do that. So potentially that could be something we could integrate. I don't know, since you said it's pretty modular and there are components that we could use. So we can talk offline as well. Sorry, because there is another topic to discuss.
Cool. Yeah. So just to conclude, sure, ping me. I mean, you anyway wanted to follow up. Very, very happy to share what we have.
Thank you so much for this. It's been really insightful, and yeah, thank you.
Cool. Thanks.
All right. Yeah. Thank you so much. Exactly. So let me share my screen again. So we have one last topic on the agenda from Jakob. It's about one of the roadmap ideas for this year. Jakob, would you like to?
Yeah,
unmute
yeah,
yourself?
sure. So it's on the project about the best practices for sustainable Kubernetes clusters, or how to make Kubernetes clusters sustainable. Just quickly about myself. Yeah, my name is Jakob, or Jacob. You can pick whatever you like. I just graduated from Aarhus University today as a Master of Science in Computer Engineering. So for the past half a year, I've been working on a master's thesis about carbon efficient Carpenter, which is a carbon efficient cluster autoscaler that can minimize the operational and embodied carbon emissions of Kubernetes clusters. So that is my background for kind of pitching in this project, and trying to see if I, together with Marta, can figure out and try to create some best practices for sustainable Kubernetes clusters. So Marta and I, we haven't even talked together yet, so we haven't done anything about the project now, but the plan is that we will try to complete the 4 steps that you, Leo, has laid out in the GitHub issue, and complete these steps within the next TAG meeting. So that is in the next 2 weeks, and yeah, basically then we take it from there. Yeah.
Awesome. Thank you so much, Jakob. And congratulations on your thesis.
Thank you very much.
Awesome. Yeah. Right. So probably you saw the message. So next to this one, which is about best practices for Kubernetes, there's also 2 other issues which we talked about in the roadmap planning for this year. So if you're interested in helping out, it would be helpful. All of these like 3 projects are intended to be, and actually there's also one, if Arne is still on the call, not sure. Yeah.
Yeah.
Yes. There's also one about the white paper and the measurements benchmarking. That's also one of them. And a third one, I think proposed by Nikki, about end user stories. So if you're interested in helping out with any of those, there are a few more ideas proposed in our roadmap planning session. So this is like the tracking issue with all the projects. A few are already, so for example, working group comms and working group green reviews is like an ongoing effort. The landscape document and the learning path are also projects we are working on, but these are upcoming projects for this year. I think very exciting, very cool and important initiatives. So you can see linked here are 3 more issues, which are basically about starting to work on the project. So have somebody who would like to feel like obligated to push this, work with the community to do measurements in this for this one, or work on best practices, talking to the community to SIG autoscaling, for example, dig into some papers maybe and just refine this and present it to the community, maybe talk about it at the conference if that's an option. Yes. All right. Are there any more last minute topics you would like to talk about? We have about 1 minute. Right. If not, I will stop the recording. Thank you all so much for attending this meeting.